Hi, I'm Mrs. Slater.
And I'm Mrs. Lindsay. The two of us will be presenting Chapter 10 video lessons.
Lesson 10.1 is all about the circle. We're going to identify the characteristics of circles, recognize chords and diameters of circles, and recognize special relationships between the radii and chords. So first of all, just a little review. We have seen this throughout the book, but starting off with a circle. It is the set of all points that are equidistant from a given point. We call that point the center, and we know already that a circle is named by its center point. For example, this one we'll call circle O. Okay, the next one is a chord, which is a segment that has both of its endpoints on the circle. So we can also place that on the circle, and we'll put chord here, connect the two of them, and we'll call that chord AB. The next one is the diameter, and in a diameter it is a special chord that passes through the center of the circle, and it definitely is the longest chord. So let's make another one. That's my circle O, C, and D. So the diameter would be CD, and the chord is AB and CD. So those are two things you should know. And then the last part is the radius, which is going to be the segment with one of the endpoint at the center of the circle and the other one at the endpoint of the circle. The radius is half the diameter. Again, this is very much review. So OD would be an example of radius. And then you could make another one just to get the point across. That would also be a radius. Okay, next we have the definitions of a circle, more definitions of a circle. The point is interior of the circle if the distance from the center is less than the radius. For example, point O, that's going to be our center of the circle. Interior of that would be point A. Okay? And next, the point interior is in the exterior of the circle if its distance from the center is greater than the radius. So for example, point C, that is exterior. Point A, and then point C. And then a point is on the circle if its distance from the center is equal to the radius. So for example, point B. Okay, now each one of these comes with a special formula. For example, if it is on the circle, again review, you may have heard the standard form of a circle, which is x minus h squared plus y minus k squared equals r squared. And the h and k represent the center of the circle. Oops, rewind. Represent the center of the circle, whereas the x comma y represents a point on the circle, which in this case is point B. And finally, the r is going to be the radius. So that is called the standard form of the circle. Now, for point A, how would we describe it using the same type of equation? X minus h squared plus y minus k squared. Still, x and y is going to represent the point on the inside, which is point A. And this one is going to be less than r squared, which makes sense because it's going to be smaller than any radius that's on the circle or any point that's on a circle. And then finally for this one, we have x minus h squared plus y minus k squared is going to be greater than r squared. The next couple definitions are here on this page. We have two circles that are congruent if and only if their radii are congruent. So for example, here's circle O, circle P, and with the common tick marks, if we can see that they both have the exact same length, therefore, we know that these are going to be congruent to each other. On the other hand, we have points let's go with R, and point Q, and their distances are not equal to each other. So if the radii are not congruent, therefore those two circles are not congruent. Another definition, concentric circles, two or more circles with the same center, and that center would be right here, circle S, right there. And one of the most common examples is the fact that we've got our store that uses concentric circles. The next four definitions and theorems represent the relationships between the radius and the chord. The first one, for example, the distance from the center of the circle to a chord is the measure of the perpendicular segment from the chord, from the center to the chord. So in a circle, here is circle X, and we have this chord. So what this definition means is that the distance between this point X and this chord is going to be a perpendicular segment. Okay, think of it as you are point X. So Xavier is trying to get to the beach. What is the closest and the fastest way to get to the beach is if he takes a perpendicular segment to the beach, or into the water, I should say. He's in the sand going to the water. So there you go. That's a definition that's going to be very important. The next one is a theorem. If a radius is perpendicular to a chord, it bisects the chord. So here's a picture to draw. Go ahead and draw a circle, and then let's call this circle Y. And also chord AB. Okay, so by definition, we know that it's going to be a perpendicular from here to here. Now, by this theorem, we can actually say that it's going to bisect the chord. So let's give this a letter M. So what we can say from this is that AM is going to be congruent to BM. Okay, the next one, if a radius of the center bisects the chord, that is not a diameter, then it is perpendicular to that chord. Okay, so it is the converse. It looks familiar because it is the converse of the previous one. Here's circle Z, and we are going to be given that a chord, the radius of the circle is going to be bisecting. So therefore, if it bisects, we know that it's going to be perpendicular to that chord. So Z, let's get some more letters in here, E and X and Y. We are going to be given, so if we are given that the radius of a circle bisects the chord, so ZY bisects EX, then what we can prove from this is that ZY is going to be perpendicular to EX. Okay, and then the last one is the perpendicular bisector of a chord passes through the center of a circle. So in this circle, we are going to look at the different parts of it. Okay, so what we would begin with is the fact that this is a perpendicular bisector. Okay, we know that this ends up with two congruent parts. We also know that that's a right angle. Now notice I have an arrow in there, so that is showing that it's perpendicular. So what that means is that it will eventually pass through the center of the circle. And that is what this theorem talks about. Okay, now for some examples. In this first one, we find that OE is in circle O, and CD is 24. So let's go ahead and write that in our picture. Okay, so if that's 24, and then the radius is 15, so that means we could put CO as 15, or we could have OD to be 15. And in this case, we're not going to need both of them. Okay, we also know from our previous theorems that OE is going to bisect CD. So I'm going to put little tick marks to show that. And then if it is bisected, then we know that each one of them are going to be 12. Okay, so because it's a right triangle and because it is multiples of one of the Pythagorean triples, we can say that this altitude is going to be 9. Okay, and then that is what we're trying to find, is 9. So OE is equal to 9. Okay, the next one, if the radius of a circle, so let's write that down first, is 30 centimeters, and a chord is 20 centimeters. Now again, the chord is going to be straight. Okay, so already just be careful with the wording. And it says a 30 centimeter chord, and we all know that a chord is going to have the endpoints of, the endpoints are going to be on the circle. So I'm going to call that 30 centimeters. And then we also know from the previous theorems that the 20 centimeters is going to be the fastest way to get to that 30 centimeters. So that right there is going to be 20 centimeters. And you can get rid of that other one. Sorry for the mess up. Okay, so it's asking you for the radius. And the radius can be connected by the center point and the end point of the chord. And that is what we're trying to find. So then if we know that a radius is going to bisect a chord, that means these guys are equal to each other. And then also each one of them is going to be 15, which then presents a right triangle with two sides given. And we just need to find the third side. And by, again, using Pythagorean triples, we know that the radius is going to equal 25 centimeters. And then finally, our last one is if we have two circles that intersect and have a common chord. So where that's going to be located is that common chord. If you want to connect the intersection, and then draw a segment to connect them, that is that common chord. The radii of both circles are 13, so that means that they are congruent circles. Let's get our center points, and they're saying this is 13, this is also 13, and their distance between their centers is 14. So a lot of things going on here. And that one's a little harder to show, so I'm going to put that in red. So that whole thing is 14. Okay, find the length of their common chord if their distances from their centers to the chord are congruent. Okay, so here again we've got both circles, and this is considered a radii from here to here that's hitting the chord. So what does that mean? Perpendicular. It also means these two are bisected. And if those two are bisected, we also know that these are bisected because of them being congruent circles. Let me get another color in here so you can see what I'm talking about. This distance from here to here would be 7, and same as this one. So those two are 7, and once again we have a right triangle. So we can say it's not a Pythagorean triple, so we're going to have to use Pythagorean theorem. So 7 squared plus b squared equals 13 squared. So b squared equals 169 minus 49. And then after subtracting that, you get 120. And as always, we want to put this in simplified radical form. And you get 2 radical 30. Okay, so when you get 2 radical 30, you're going to take that. What we have just found is this length right here. Okay, so if that's 2 radical 30, then we're going to have both of them added together. So taking both of those, and I know you can't see that very well, so 2 radical 30 plus 2 radical 30 for a total of 4 radical 30. And that would be the length of the common chord. And that ends 10.1 notes, and we'll see you tomorrow, or no I won't, because this may not be my class. So good luck on 10.1.